morning, we're at the Backwoods Homestead. We're going to make a geothermal heater with our well pump. So we're going to keep this as cheap as possible. I have a what's called a water to air heat exchanger. They're normally for wood stoves. This is roughly like 150,000 BTUs at 180 degrees. So we're using 65 degree water. So what does that count for? I have no idea. I'm not doing the math. And then we have a cheap baking sheet. We got all aluminum, so it doesn't have corrosion. That and this should be aluminum too. I know the fins are aluminum. I don't know about the housing. But either way, we're using a brick, and we're going to put the brick in the center of the drain pan. And then we're going to set the heat exchanger up to that. And that way it'll actually, when the wind blows, it'll stay above this lip here on the pan too. And give it proper airflow and so on. And yeah, there's probably better ways. Yes, some air is going to escape past the heat exchanger. But I believe it'll be okay. We could always put 2 bricks in there to help solve that problem, keep it tighter. And then it's 1-inch copper on the top and the bottom, and really doesn't matter which one's which. And then I just have an 8-inch plenum coming off right now with a dampener. Not sure how much air we're going to get out of it. We're just going to use a cheap box fan. Just a cheap box fan, get them for 20 bucks. And then I just made this plenum. I had just stuff laying around. It is 21 by 22 on the inside. And I really don't even have to put a cap to it, considering it's just the box fan's gonna take up the whole entire back side of this. So it really doesn't matter if it's sealed. I was gonna get one of them cheap blue media filters, or maybe an actual air filter, and put it on the return side of the fan to help so this doesn't get clogged up over time. And then just now I had a thought that, well, I might get really good results if I left this end completely opened. So I'm probably going to just cut it off here after I get it up and running to see what the difference would be with the volume of air and stuff. Unfortunately, I got a lot of toys, but I don't have anything to measure air volume, cubic feet per minute. They do make such a tool. It looks just like a little fan, and it blows it, and you tell how big the box is, and it'll tell you how much you're moving. So if anybody wants to donate one of them to Backwoods Homestead, you're more than welcome to. For this part, I'm actually just using a bimetal hole saw. A brick fits here and a brick fits here, so being dead center, that kind of helpful. Always go on number 1 slowest setting, and if you're not familiar, you can always put on a clutch setting, so if it bites fast real hard, the drill should stop and it don't twist your arm off or get hurt as easy. For this particular part in the hole, we're just using a sink drain to give it a fairly low profile. And then it does have a strainer in there too, maybe help clean it out a little bit. Probably going to take that out just so it don't cause problems. And then for the other part, we're going to drill a hole into this, so then the condensate can go right out the bottom. And we're going to put that into a 55-gallon drum because we're going to measure the condensate. But also, when you have air to water heat exchange, there's a lot of BTU calculations on that, and I think that might help us get a gain, so it's another part of this experiment. So now we're going to install the drain on the pan, and the best way to do this is to put sealant on the actual drain itself, which is just 100% silicone. Make sure that it's 100%, nothing else, you don't need anything else. And you put a nice thick bead along here. And this could get a little on the sloppy side because it's a very big bead. But I'd rather have more than not enough. That's all there is to it. Now, I probably could have filed these edges down and whatnot, but the main thing is we're never in a perfect world. And so that's why I do this here too. I put a nice, decent, thin layer of silicone on our rubber gasket. Because there's imperfections in all types of manufacturing, castings, this and that. You wouldn't believe how many times where if I wouldn't have done this in the field, I would have never got a good seal. So that's very important to do that also. So what we'll do is we'll stick our drain in the hole. And then just kind of squish it in. Rubber gasket goes on next on the back side or bottom. And then a nut. They make a tool that goes in here to tighten that all down and stuff. But I have it in the truck. I don't think it's going to fit this one though. This is one of these cheap camper ones. I just bought it for $7. I figured it would be flatter than sticking a male adapter up with a nut, because then I'd have to grind the male adapter off and I'd still probably have like an inch sticking up, so there wouldn't be much room. So you just crank that down as hard as you can. Now here's the very important trick that not many people know. If you spray alcohol over top very liberally, then take your paper towel and wipe up the excess. %90 of that crap that you can't get up is up, because this is a very good trick. And you can do it one more time just to make sure. This doesn't matter so much, ain't nobody ever gonna see it. I'll give you a good demonstration how good of a trick this is. So now you can drain your own cooking in the middle of your oven. No, I'm just kidding. And now I don't know if that's tight enough, so we're going to put a wrench on it just in case. Okay, so now we've got our wrench on here. There's nothing really to hold the middle, but the middle's not spinning, thank the Lord. And we're squashing her down here pretty good. I don't want to go too much further, considering this whole entire thing is nothing but plastic. And then you'll see we got a little bit extra here, but no big deal. We'll wipe it up here in a minute. Then the back side, I like to just kind of smear it all around that nut and fill in any holes. Make sure that is a seal, because the seal on the bottom is just as important on the top, because if the top fails, guess what? Maybe your bottom will save you. And a lot of times they don't seal for crap up top, because some drains have a taper, some drains are flat. I should have showed you that beforehand. But anyhow, ain't nobody gonna see that part there. So now you can tell that just fits so much tighter, and that'll make everything work so much better. So the next thing I'm going to do is just put a little thread tape on the drain, and that way I can put a PVC adapter on. And one thing that does is that makes it so I can get it down past the duct board, so I know I'm not going to get it wet. And two, I can hook up to it later on if I decide that I don't want a water collection barrel underneath, and I can just pipe this anywhere. 1.5 inch is very big. Normally I do like 1/2 inch or 3/4 for condensate, but I have two factors in this, and one is that the condensate drains tend to get that black moldy crap in them all the time. And so if you have a bigger pipe, I have a feeling that you'll have less of a problem. But I could be wrong. There's really only one way to find out. And then two, I can always push it down later. Now we're going to put our drip pan inside and stick that right down in there. That sits nice and flat. And we're going to put a brick on each side. And then we're going to put the exchanger on top. And one thing I should have done was I should have had this all out here and measured where the pipes was originally. Now I got to do all that again. So like an idiot, I didn't think twice about the pipes being offset. Luckily I drilled a big enough hole as I wanted to be able to put insulation around it so it don't sweat where the pan is not there. Other than that, everything's going smoothly so far. I'd like to have Mostel Repair be noted by sponsoring this video. We got a lot of specialty equipment on the job site today, and thank you for coming out. I haven't got this one out in a long time. This is a 1-inch Pro Press. Crimps right down on 1-inch copper. Goes up to 1.25 inches if need be. Basically, just come right up here on the fitting, go around it, and hold the button in. And that makes her tight. In case I forgot to tell you, I'm working with a 16 by 16 inch air to water heat exchanger, and you could use any size you want. Some people are using car radiators. However, I'm putting this water back into my well system as soon as I get everything approved. For experiment purposes, I'm just dumping the water out on my deck until I find out all of the chemistry with the water. Raising water temperature can change like manganese and iron contents and a few other things. So now we have the heat exchanger in place and the fittings on the outside. I had to put them on and then shove the whole thing through, which is also why you need a bigger hole than you're supposed to. But we'll show you how to finish all that next. And then the next thing I'm going to do is there's a gap here, so I'm going to put another 2 set of bricks in there to kind of tighten that gap up to force as much air through the heat exchanger as possible. We have our whole thing temporary set up. I got the plumbing come off the filtered water from in the basement, and then I got a garden hose going straight out the window. The room temperature says 77. The top part's humidity, so disregard that, sorta. Be 60% humidity, which could be important in this test also, because we're going to be condensing the air. And I taped off these holes sorta till I get pipe insulation. I forgot about that. So now we're going to turn the water on and see how cold this baby gets. And it's dropping already. Too bad I don't have a way to see inside there real good. I don't see any condensation yet. It's kind of stuck at 69 degrees, which isn't as cold as I was thinking it was gonna get. I was hoping for at least 64, 65. So now I'm going to measure the pipe temperature. So the incoming water temperature is going down to right around 61 degrees. So that means I still got 10 degrees difference roughly between what the incoming water temperature is and the outgoing air temperature. So the outgoing water temperature is about 2 degrees warmer. So now we were able to get 66 degrees off the air. And that's more closer to what I'm looking for. Still have 59 degrees for incoming water temperature. And right around 60 degrees for the return water. So we're not taking a whole lot of heat out of the water. Put the fan on low speed to see if it would cool the air because it goes across the fin slower. And now we're back up to 70 and a half degrees. It's been 25 minutes and we've brought the humidity down 2%. It has not changed the temperature at all. It does feel cooler in here though. I don't know if it's because I'm standing next to this thing. I mean, right here, I could stand here. This is great. Saying that it is 65, 66 degrees. I experimented with turning the return on like a half a turn and this and that, and it seems to want to jump up to 70 degrees. So that flow does make a difference. It might make a bigger difference if I had a bigger heat exchanger. I wish I had different ones I could try. I also jammed this pair of sweatpants in here to force all of the air to go through the heat exchanger, just because that's the quickest, easiest way to see if I had different results. I believe that helped, maybe by a degree or two. We have a submersible pump coming in, and our gauge is holding steady right at 65 pounds. So with that open flow, we're really pushing the water. Then it comes in and then through then we go a whole house water filter, and it comes into this thing. This is kind of like a whole house water filter too, but it flushes itself out. And then it goes into a water softener, which we have in bypass mode right now because we don't really need to soften the water, just to dump it, and a bunch of variables. Then this red pipe coming off, that's what feed it back over. This is all just thrown in here for temporary sake, and it should all be insulated because you can see that there's a lot of moisture on the pipes. Actually, all these pipes should be insulated. It's going to cause dampness if I don't. But we'll do that later on after I finalize things. Also, that has a 50-70 pump switch in it. So that's why the well doesn't turn off, because it hasn't gone all the way up to 70 pounds. Now if I cut the flow back some, the pump would kick on and off, on and off. That also gives it time for the water to warm up inside the basement a little bit also. So we're at 64 degrees. Nice and cool coming out of this. We've lost 1 more percent. We are at 57%. Still at 77 degrees. but it feels nice in here. Now you're wondering how much electricity the well pump's using. Well, startup's one thing, but we'll do this leg first. Be 5.7 amps. And then we have to do the other leg because it's 220. It'll be 5.6 amps. Now it was 5.6 on the other one earlier. Yeah, close enough. Half an amp ain't gonna matter one way or the other. Now you can't go and do all the wires at once because it'll give you an incorrect reading. You have to always isolate the hot from the common and the ground. And if there's two hots, you have to do each hot individually and then add them together. So 5.5 will make it easy. So it'd be 11 amps. 5.5 plus 5.5, or a little bit over that, 5.6. This is what they call a circuit isolator. So the common's on one side, the power's on the other, and we can get the amperage reading this way. So our air conditioner is at 5 amps. 5.4. Now since there's only one hot, that would be why it's like that. And we're doing the box fan now, and it's 0.56 amps. There, now you can see the better. It has been exactly 1 hour now, and we've dropped 5% in humidity and 2 degrees in temperature. And yeah, this is right next to it, but it's blowing that way. And you can definitely feel a difference in here. So now we're going to measure what a air conditioner puts out compared to this unit here. So we're pretty close to the bottom line of this. It might go down 1 more degree or so. It's just a old LG 8000 BTU window air conditioner. Nothing spectacular. And so we're within 1 or 2 degrees of what I'm actually putting out at my new geothermal type heating cooling unit. What makes it heating and cooling is if it's only 10 degrees outside and you're blowing 64 degree air in your house, that's pretty warm. Then you can just add a little extra heat and you got what you need.